Okay, let's work on the rational function worksheet. All right. So we have this graph. And so the first thing I asked you to find is x-intercepts, their multiplicity and their behavior. So it looks like it touches x at -3. So that x-intercept is -3, 0. And it appears to be a multiplicity 2 because it bounces. Multiplicity of 2 because it bounces. And it looks like there's another one at 2. And it also bounces, and so it has a multiplicity of 2, or 4, or 6. Y-intercept. It looks like it crosses the y at about 6. Vertical asymptotes. Well, this is moving over. It's rising less steep than this one. So I'm going to guess, if the professor had any kind of decency here, made it maybe at 1. So I'm going to say a vertical line at x equal 1. And since it looks like both of them go up, it's going in the same direction. So the factor that's causing this must have a multiplicity of either 2 or 4 or 6 or something like that. And there looks like there's another one here at 3 if I follow this down. Now this is 4, and it looks like this is going to cross 4. Oop, you can't see where I'm pointing. Going to cross 4 and come over here. So I'm going to guess at 3. And they're going in opposite direction, so it's either 1, 3, or 5, and because they're going in opposite directions. Okay. Domain. So looks like this graph exists all the way up until about 1, where it appears it disappears. So it goes from -infinity up till 1. Then it disappears. Then it comes right back between 1 and 3, and where it disappears again. And then disappears at 3, but then it shows back up down here. So from 3 on, it's back. Range. Okay, to get the range, it looks like this goes down till -infinity. So from -infinity up to here, about 8, -8 point, middle of 6, 8 points, so it's 8.5, so it looks like about 8.6. From -infinity up to -8.6 something. And then it's gone until we get to a height of 0, and it exists at 0 and on up. At least that's what it appears. So includes 0 to infinity. When is this graph greater than 0? Y values. For what x's is the y greater than 0? Looks like all of this is greater than 0 except at 3. -infinity up till 3. And then right after 3, it looks like it's greater than 0, clear up till 1. 3, it's equal to 0, that's why we're skipping it. Up to 1. At 1, it's gone, but it reappears positive and ends up being positive till 3, and then it disappears. So from to 3, what did I do here? Greater than 0, from negative infinity till 1. Oh, till 3 right there, and then 3 to 1, and then from 1, oh, negative 3. There's what my mistake is. I couldn't figure out what I'm doing wrong here. Negative infinity to negative 3, and then from negative 3 to 1, and then from 1 to 3, and then after that it's all negative. All right, so what is the function? Well, the numerator gives me x-intercepts. If there's an x-intercept at minus 3, the numerator must have an x plus 3. And if it bounces, it must have multiplicity 2 or power of 2 or 4 or 6. We'll go with the simplest. And then also at 2, so that means x minus 2 bounces, so power 2. The denominator has causes asymptotes, and there's 1 at 1, so there must be an x minus 1, and it must have at least 2 or 4 or 6 because it goes in the same directions, and it must have an x minus 3, and that one probably is 1, maybe 3 or 5. Now, this has an oblique asymptote, a sloping line that this follows. So the degree of the numerator has to be 1 more than the denominator. Do we have that? So this is 2 and then another 2, so this got degree 4. And this has got 2 and another one that's degree 3, so 1 more than the numerator is 1 higher degree than the denominator, which would have an oblique asymptote. So that looks pretty good. Now there may be something here that multiplies by this to give us the actual function. Now to figure out the a, we can use this x-intercept or any other point that we know well. X-intercepts, or y-intercept, excuse me, we can use the y-intercept because that allows us to use 0 for x, and we're supposed to get 6. So I'm going to put in 6 in for the f of x or the y equals a times, now I'm putting 0 in for all of my x's because that's what a y-intercept is. And so I get 3 squared, which is 9, times minus 2 squared, 4, over minus 1 squared, 1, and 0 minus 3 is negative 3. So this is 36 divided by negative 3 is negative 12, times a is 6, so if I divide by negative 12, I get a has to be negative 1/2. Okay, now to do these last ones and to see this graph, I've already taken my phone and typed in everything except the negative 1/2, and you can see that it looks like this, only upside down. Well, the negative, let's see, there we go. The negative would flip it over, so let's put in the negative. Now it's flipped over, but this, you can see, has a y-intercept at 12. And this one had a y-intercept of 6, so we need to vertically squeeze it by a factor of 2, which was what would happen if we put a 2 in the denominator. And there's that negative 1/2. And now we have, let's get this out of the way. And we pretty much have what's on the graph. Maybe spread it out a little bit this way. Whoop, that made it taller the other way. But yeah, notice this is at -8, -9, so -8.60 something. It asked us to find maximums. Well, this is a minimum, that's a minimum, and there's a maximum. So we could just look at the graph we have there, but we can get even a better answer by tapping on there. Looks like our maximum is -8.62595. And our minimums, there's 2 of them, but they're both 0. So my minimums are a height of 0. Right there and right there. Okay, that's the front page. Back page. So to start this problem, I'm going to get rid of that, and I'm just going to type the numerator in, and I'm just going to call it some function like f of x. So ABC f, put that back. Let's see, where do I go back? Oh, back there. F parenthesis x parenthesis. Whoop, it's doing subscript. I don't want subscript. Now I lost the f. F parenthesis x parenthesis. Hard for my big fingers on the little phone. F of x, and I'm going to do the numerator. Do it where you can see. So equals, and you'll see why I'm doing f of x, and I'm going to do g of x here. I'm just going to do just the numerator. X to the third, there we go, minus x squared minus 4x plus 4. I think I have that in right. Now let's see if I can see any x-intercepts. Oh, there's some x-intercepts. Looks like it goes straight through at -2. So that numerator must have an x plus 2 in it. Straight through, so probably 1. Looks like it goes straight through at 1, so that means x minus 1 is a factor, and it goes straight through at 2, so x minus 2 is a factor. So I think that's what the numerator looks like. Now I'm going to go get rid of that. I'll go here and put in g of x. I'll just call it g. Could be h, could be anything. Back to this, parenthesis x parenthesis equals, I need smaller fingers. Oh, maybe my pen will work here. 2x to the 4th minus 14x to the 3rd plus 26x plus 26x squared. Didn't get the 2. 26x squared plus 6x minus 36. Okay, let's turn the purple one off. The green one looks like it goes straight through at minus 1. So that means x plus 1 must be a factor. Goes straight through at 2, so x minus 2 must be a factor. And it bounces at 3, so x minus 3 squared must be a factor. This would have a leading coefficient of not 2, but 1, so we need to put a 2 here. And I think that's what this function factors to. Okay? Now, a hole is caused if there's a number that we can't put in because it causes division by 0, but the same factor shows up in the numerator. So these two could be canceled out and we'd get something that's almost the same, but not quite. So I should say it's similar to x plus 2, x minus 1, and 2, and x plus 1, and x minus 3 squared. This graph and this graph look exactly the same when you put them on Desmos, but they're not the same. This one you can't put in 2 because you get division by 0. This one you can put 2. So there's a hole at 2, and to figure out the y-coordinate at 2, you put 2 into the one that doesn't have the hole, and you'll figure out where the hole is on this one. So if I put 2 in here, I get 4. 2 plus 2 is 4. 2 minus 1 is 1. And we have a 2. And we have a 2 plus 1, which is 3. And a 2 minus 3, which is minus 1 squared, is 1. So we have 4 over 6, or 2/3. So that's where the hole is. Now, when I graph this, I should see 2 and undefined, but it should be really close to 0.666666, 2/3. Okay, determine the equations of the vertical asymptotes. There's going to be one at x equal minus 1, and not at the 2 because that was a hole, and one at 3. And the behavior there, well, at minus 1, it happens once, so it's got the curve is going to go in opposite directions there, so one side's going to go down and one side's going to go up. At 3, that happens twice, so they're going to go in the same direction. Okay? Now, this is a little bit more complicated. We have to look at the degree. The degree of the numerators, 1x to the third, or 3. Degree 3, x to the third power. This one, if I multiplied it out, it's x to the 4. This is degree 3, degree 4. So x to the third over x to the fourth with a 2 in front. This, as x gets really large or really small, like 1,000 to the fourth, 1,000 times 1,000 times 1,000 times 1,000 is trillion. So this is 2 trillion, and this would be only 2 billion. So this is 1,000 times smaller, or 2,000 times smaller than this. This fraction is getting really small. It's like 1/2000th. And so it's getting closer and closer to 0. So this is going to have a horizontal asymptote of y equal 0. As we go out, it's going to get closer and closer to 0. Now, just for an explanation here, if this was degree 4 up here, then these would be equal and cancel, and it would approach 1/2. If this is higher, 5/4, this would form an oblique asymptote like we had over here. The degree on this one, the numerator was 4, the denominator was 3, and so it has an oblique or slant asymptote. This one doesn't, so it just goes towards y equals 0. X-intercepts, well, that would be at -2, 0, 1, 0, and that was a whole, so we can't count that one. And at -2 and at 1, they're both multiplicity 1, so the behavior is straight through, straight through. Y-intercept, you put 0 in for the x's, we get 4. Put 0 in for the x's, we get -36. 4/-36 is -1/9 when you put 0 in for the x's. Now you can put it in here, it's a little more complicated. It's easier to put 0 into this, get the 4, put 0 in for all those x's, and we get -36. 4/-36 is -1/9. Now we want to graph this. Okay, now you don't have to graph it. You can probably figure this out already, but since we've got this here, let's see, get my phone going again. All right, so here it is, except I want to do f divided by g, because f is my numerator and g is my denominator. So I'm going to turn g off and type down here, come on, I'm going to type in f of x, if I can, wrong one, f of x divided by g of x, and I got too many parentheses there. Take one off. Oh, bad news. All right. F of x divided by g of x. And here's a picture of what this curve looks like. And it, excuse me. Do you see how it's avoiding -1? Come on, stay on. Avoiding -1, vertical asymptote, and they're going in opposite directions. It's avoiding 3, going in the same direction. Has a y-intercept of 0, -1/9. If I tap on that, -0.1111 is -1/9. Has x-intercept of -2. Now, kind of hard to see that bounces there, so we need, let's, I don't want to add something. I want to get this out of the way. There we go. It's hard to see. I need to look closer. There you can see that it goes down below 2 and down below the line. So it goes straight through at 2. And it also, that's one x-intercept, and at 1, it goes straight through. That's not an hesitate. Hesitate looks a little different than that, but not very much different. Okay, so we've graphed it. Now, the question said, find out when this is the y's, for what x's is y, for what x's is y less than 0, the height less than 0. Okay, so over here, it's less than 0, clear up until it gets to minus 2. So from negative infinity to minus 2. Union. And then it's positive. It's less than 0 here, and it's less than 0 clear up till 1. From negative 1 to 1. Doesn't exist at negative 1, so a parenthesis on it. And it's equal to 0 at 1, so we don't want to include it because it's not equal. And then after that, it's positive. Then after that, it's still positive y's, and it stays positive forever. So there's when the function's less than 0. Now, when is the function increasing? So let's go back over here. And you notice how it's getting closer and closer to the y this way. So if I'm reading left to right, it's going down lower and lower and lower. And then all of a sudden it starts going back up. So somewhere along in here, there's a place. Oh, since it highlights it on Desmos, that's telling me that's probably the minimum. So it's decreasing up to here, then it starts increasing. So at negative 5, it's not determined, but after negative 5, it's going up, and it continues to climb all the way to negative 1, where it goes out of sight, off to infinity. Then right past negative 1, it comes back from negative infinity, so it's increasing again, coming up. So at negative 1, it starts coming just past negative 1, it's coming up, and it keeps going up. And I'm tempted to say clear till 3. However, I got to remember that there was a hole at 2. At 2 and something. So now if I see if I can show this, I got to hit 2, which is going to be really hard. Oh, there! Oop! I saw it. Come on back. 2. 2 is undefined. Twice, a couple times. It's hard to see holes. There it is. 2 is undefined. Just either side of it, we're at about 6.9 or 6.5, 6.77, 2/3, 0.677. So at 2, this graph disappears for just that 1 point. And so I have to stop the increasing. It doesn't exist at 2. But then right after 2, it's still increasing. So I'm going to go on from 2 on till it increases till we get to 3. And then the graph starts coming back down, and it keeps coming down for the rest of the way. And so that's all the areas, all the x intervals where the y is getting bigger and bigger as I go from left to right.